Hi guys, today we're going to be looking at limiting reactants, and the way we're going to do this is we are going to make our own do-it-yourself lava lamp using some common household items. The first thing you're going to need is going to be a clear plastic bottle or a jar, something to put your ingredients in to make your lava lamp. You're also going to need some water. You're going to need some vegetable oil, some food coloring. I like green, so I'm going to make mine green. We're going to need some Alka-seltzer, and just for fun, because I like things glittery, we're also going to add a touch of glitter today. So here in my Alka-seltzer packet, we have a couple chemicals. We have citric acid and sodium bicarbonate present. And when those two chemicals react, they perform what's called an acid-base reaction, which means that these two ingredients are going to react together to neutralize any acid-base reactions, or properties, sorry. They're also going to produce a salt. It's why Alka-seltzer does such a great job at neutralizing the stomach acid that's backing up into your throat that's causing that heartburn. It's what's going to alleviate the symptoms. It's going to neutralize that acid. Okay. So if both sodium bicarbonate and citric acid are present in our Alka-seltzer, why don't they react while they're still in the package? So first of all, they're in a solid form, which means even though there might be some small reaction occurring, the molecules are not going to collide with each other very often. They're going to be very slow. It's going to be a slow reaction. When we place our Alka-seltzer in water, it's going to dissolve the solid, and it's going to be, what it's going to do is it's going to allow those molecules to interact and collide with each other at a more rapid rate, and thus speeding up the reaction that's going to occur. Okay. So the first thing we're going to do to make our lava lamp is we're going to take our jar, and I'm going to fill it up about a fourth way with water. So I don't know if you can see that there. So I'm just going to kind of estimate there, I'm going to eyeball it. I'll put about that much water there, so about a fourth or so. And then the last 3/4 of my jar are going to get filled up with my olive oil. I'm going to make sure that I'm going to leave a small space at the top for some gas to escape. I'll leave about that much at the very top for my gas to escape. Now, I like things pretty. Like I said, I like it green. And well, first of all, let's talk about the density here. So here we have water. Water is a polar molecule. Oil is not. And so since water is polar and oil is not, the two liquids, they're not going to mix together. They're going to remain separate. And since oil is less dense than water, it's going to float to the top, and our water is going to be down at the bottom. Okay. When I put my food coloring in, my food coloring is also a polar molecule, and so it's going to sift through the oil and basically mix in with my water at the bottom. We're just going to put about 8 to 10 drops in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So it's working its way down to the bottom. It's going to mix in with the water. Like I said, I like things sparkly. So I am also going to put a little bit of glitter in. And we're just going to make it a happy lava lamp. Okay. So got this glitter. I'm going to go ahead and mix this just a little bit. Just to make sure my food coloring kind of sits in there. Okay. I'm going to make my water nice and green and glittery. So we're going to let that separate out, and then we'll proceed to put in our Alka-seltzer tablet and see the reaction. And we're back. Sorry, I was a little too exuberant in mixing my water and food coloring and my water together, and so I shook it up. It took quite a bit of time for my oil to separate. So instead of waiting for it to separate while we were recording, I went ahead and hit pause and came back, and so now it's separated. Okay, so now again, since oil is less dense than water, the oil is sitting on top and my water is down at the bottom, okay, with my food coloring in it. And so what I'm going to do next is I'm going to add my Alka-seltzer tablet to make that lava lamp effect. And so our citric acid is going to react with our sodium bicarbonate. So we have 1 mole of citric acid and 3 moles of sodium bicarbonate that are going to react to make 3 moles of water, 3 moles of carbon dioxide, and sodium bicarbonate. Okay. So I'm going to take this lid off here. I've got my Alka-seltzer tablet. I'm going to break it in half, or in a couple pieces. I'm going to go ahead and add them to my lava lamp here, and there you go. You can see right away bubbles are being formed there, which is evidence that a chemical reaction is taking place. Okay, and so those bubbles, what they are is they are carbon dioxide gas. Okay, and what they're doing as they're rising to the surface, since carbon dioxide is less dense than both the oil and the water, it's kind of hanging on to some of the water, and so it's pulling some of those water droplets up with it as it rises to the surface. Once it gets to the surface, those carbon dioxide bubbles, they pop, they're released to the atmosphere, and there's nothing hanging on to the water droplet at the surface. And so what that happens, since water is more dense than oil, it's going to fall back down into the water, creating that bubble lava lamp effect where it rises and it lowers and more rises and it lowers. Okay, and it's going to keep going on and on and on. In our case, since we are running a chemical reaction, this is going to keep happening until I run out of sodium bicarbonate in my Alka-seltzer tablet. Sodium bicarbonate is the limiting reactant in this reaction. So since sodium bicarbonate is in a fixed amount in the tablet, it's going to keep reacting until we run out. Okay? And so a limiting reactant, again, is the reactant that is entirely consumed when a reaction goes to completion. And so when we run out, the reaction stops. No more bubbles getting produced, and no more CO2 or carbon dioxide. In order to get this reaction to keep going, what I'm going to need to do is I'm going to need to add another tablet of Alka-seltzer. So I'm going to have to add more sodium bicarbonate to my water in order to get it to dissolve and start the reaction again. Remember, sodium bicarbonate and citric acid are reacting. I'm going to add another tablet, and we should see the reaction start up again. And there we go. More carbon dioxide is being produced, and so we have more bubbles. Once it consumes the sodium bicarbonate, once again, our carbon dioxide will not be produced anymore. So therefore, sodium bicarbonate is our limiting reactant.